Allow me to reset the stage. I believe the best place to begin, as always, is with the raw data, the numbers. You see, human beings have a peculiar disconnect with immense figures. We hear phrases like billions upon billions of stars, and we nod in agreement as if the scale is comprehensible. But we don't truly internalize it, not on a visceral level. So let's try to internalize it for a moment. Our home galaxy, the Milky Way, this immense rotating disk of matter we are currently traveling on without a second thought, is home to an estimated 200 to 400 billion suns. This isn't a turn of phrase. It isn't a poetic flourish. It is a statistic. 400 billion, and orbiting a great many of those suns are planets. This is something we now know for a fact. The Kepler Space Telescope journeyed out, focused on an incredibly small segment of the night sky, a spot no bigger than your clenched hand held at arm's length, and in that minuscule window, it discovered thousands of worlds. When you extrapolate from that data, and this is the moment I truly appreciate, when the sheer force of the mathematics takes hold, you find there are likely more planets within our galaxy alone than there are individual grains of sand on every beach on our entire world. And our galaxy is just one of an estimated 2 trillion galaxies within the portion of the universe we can observe. So, when people pose the question to me, do I believe there is life elsewhere? I feel compelled to respond that the question itself borders on the absurd. The cosmos is so mind-bogglingly expansive and so ridiculously saturated with the necessary components, carbon, hydrogen, oxygen, nitrogen, water, that the truly astonishing outcome would be if we were the sole inhabitants. The genuine shock would be if, across all this expanse, across all these billions of years and trillions of galaxies, the chemical processes of life ignited only a single time, right here on this slightly moist piece of rock, orbiting a completely unremarkable star in a less than prime location in the outer reaches of an average spiral galaxy. That would be the anomaly. That would be the phenomenon demanding a special explanation. But this is the point where the topic becomes truly compelling. This is the moment I need your full attention, because this is the aspect that many people tend to skim over, as it evokes a certain discomfort. There was an astronomer by the name of Frank Drake. In the year 1960, he aimed a large radio antenna at 2 nearby stars and simply listened. He was listening for transmissions, for any indication that someone out there was sending a signal. He dubbed this endeavor Project Ozma, after the Queen from the Oz books, a choice I've always found to be a mark of refined taste. He detected nothing. However, the process itself sparked an idea, and in 1961, he formulated what is now known as the Drake equation. Now, I need to tread carefully here, because this formula is simultaneously one of the most celebrated and one of the most profoundly misinterpreted equations in the history of science. People see it and assume Drake was calculating the definitive answer to life, the universe, and everything. That wasn't his goal. He was organizing a conference. He literally devised it to provide a coherent framework for a meeting's agenda. But the function it serves, and serves with elegance, is that it compels you to confront with stark honesty what you know versus what you do not. The equation directs you to multiply a series of variables to arrive at n, the number of civilizations currently existing in our galaxy with whom we could theoretically establish contact. You begin with the rate of new star formation. That's fine. We have a fairly solid grasp on that figure. Perhaps a handful of new stars are born each year in the Milky Way. Next, you multiply by the percentage of those stars that possess planetary systems. We also have good data on this now. It's a high number. It seems most stars likely have planets. Then, you consider what proportion of those planets exist in the habitable zone, not too close to their star, not too far away, where water could remain in a liquid state. We can still make reasonable estimations here, okay? And then, this is the point where the ground gets unsteady. You multiply by the fraction of those suitable planets on which life actually emerges. And here is the unvarnished truth. We possess a single data point. Earth? We have no way of knowing if life's beginning here indicates it's a common occurrence, or if we were the beneficiaries of an extraordinary cosmic stroke of luck. We don't know. One data point. I must be transparent with you about that, because this is the essence of science. You do not feign certainty about things you cannot know. From there, it becomes even more speculative. What percentage of that life evolves to become intelligent? What percentage of that intelligent life creates technology and begins transmitting signals into the cosmos? And for what duration do they continue to transmit before? Well, before they go silent? That final variable, the lifespan of a communicative civilization, that's the one that ought to give you pause. Consider our own case. We have been sending radio waves out into space for approximately 1 century. 100 years in a galaxy that is 100,000 light years in diameter and roughly 10 billion years old. We are infants. We are less than infants. We are a single fleeting note in a cosmic symphony that has been playing for 10 billion years. And the unsettling question is, how long do societies like ours tend to endure? We possess nuclear armaments. We are altering the climate of our own planet. We have shown time and again that our wisdom frequently fails to keep pace with our ingenuity. So perhaps the universe is teeming with worlds that gave rise to life, which then developed intelligence, reached a stage comparable to our own, and subsequently fell silent for one reason or another. This concept is known as the Great Filter, and it is either in our past or in our future, and that distinction is of monumental importance. If the Great Filter is behind us, if the difficult step was the transition from inorganic chemistry to biology, or from simple cells to complex organisms, or from animals to creatures that can ask, "Where is everybody?" then we are a rarity. We are precious, and perhaps the cosmos is largely uninhabited, with the path ahead clear for us. But if the Great Filter lies before us, if intelligent technological societies have a built-in tendency to self-destruct around the time they become powerful enough to inflict catastrophic damage, then the silence we observe has a very grim explanation. Then the silence serves as a warning. I don't know which of these is true. I want to be explicit about that. I don't know. No one does. And I believe that acknowledging our ignorance and being honest about it is the first step toward genuine understanding. But let me share something I find even more captivating than the Drake equation. Let me tell you about a question my friend Enrico Fermi posed during a lunch meeting one afternoon in 1950. Fermi was a genius. I mean a true genius, not in the casual way that term is often used. He constructed the world's first nuclear reactor beneath a squash court in Chicago. The man perceived things on a level that is exceptionally rare. And one day at Los Alamos, he and his colleagues were eating lunch and discussing sightings of UFOs. It was 1950, and stories about flying saucers were common in the news. Fermi, as he was known to do, performed a quick calculation on a napkin, then looked up at his colleagues and asked, quite simply, "Where is everybody?" That's it. That's the entirety of it, those 3 words. Where is everybody? You see, this was his calculation. If other civilizations exist, and if they emerge at the rate that optimistic interpretations of the Drake equation suggest, then some of them should have started their journey billions of years before we did. And even with technology only moderately more advanced than our own, a civilization could dispatch self-replicating probes or colony vessels and populate the entire galaxy in perhaps 10 to 100 million years. That may sound like a vast amount of time. It is not. The galaxy is 10 billion years old. A civilization that arose 2 billion years ago could have explored every star system in the Milky Way multiple times by now. They could have come here. They could have left some indication of their presence, but we find nothing. No signals, no artifacts, no inscriptions carved into the surface of the moon, no bizarre megastructures around distant stars that defy natural explanation. Well, for the most part, there are a handful of anomalies we cannot yet explain, but nothing that can be considered conclusive. Nothing that has survived rigorous examination, just an overarching silence. Now, this is the point where I want to do what I always strive to do, which is to pause and consider if we are framing the question correctly, because I suspect there are multiple ways in which we might be deceiving ourselves here. And the foundational principle, the one I consistently return to, is that you must not fool yourself, and you are the most susceptible person to your own deceptions. Let's consider what it would actually take to find us. We've been transmitting radio signals for about 100 years, the very edge of our radio presence. The bubble of space that has had any opportunity to detect our transmissions is about 100 light years in radius. Our galaxy is 100,000 light years in diameter. So our little radio bubble, the sphere of which we are so proud, occupies roughly 1,000th of the galaxy's width. In terms of sheer volume, we filled a space so minuscule that I would need some time to write down all the zeros in the fraction. We are not shouting into the void. We are murmuring. And as you move further from a radio source, its signal attenuates. It dissipates over an ever-expanding area. Our most powerful television signals become indistinguishable from cosmic background radiation after just a couple of light years, maybe a few more if you possess a highly sensitive receiver. The nearest star to us is 4 light years away. Even to our closest neighbor, our presence is already dissolving into the cosmic static. So when we ask, why haven't extraterrestrials discovered us? A significant part of the answer might be that we simply haven't been transmitting loudly enough for a long enough duration. We have existed as a technological society for a mere blink of an eye in cosmic terms. And for most of that blink, we've been broadcasting very faintly. In a galaxy that is 100,000 light years wide and 10 billion years old, this doesn't amount to much. But there is another aspect, one that I, from a physicist's perspective, find even more compelling. And that is the question of what we are searching for, and whether we would even be able to recognize it if we found it. We scan the skies for radio signals. We look for pulses of laser light. We conduct our search using methods that are logical to us in the year 2024, based on our current level of technology and our present-day theories about how communication functions. But consider this. A civilization that is 1,000 years more advanced than our own would view our radio telescope surveys in the same way we would view someone trying to detect messages in the ocean by sampling the taste of the water. The medium would seem nonsensical. A civilization 1,000,000 years old might communicate through means we have not even begun to conceptualize. They might employ a medium for which we don't yet have a name. They might have moved entirely beyond the electromagnetic spectrum for their communications, or consider it from their viewpoint. If they are searching for us, if some alien astronomer is aiming the equivalent of a radio telescope at our solar system, they would need to be looking at the precise right moment, which is within the last 100 years or so, and at the exact right frequencies. And they would have to interpret their findings correctly. And they would have to be near enough for their signal and our signal to traverse the distance between us within the lifespan of a civilization. The universe is indifferent to our impatience. Signals propagate at the speed of light, which feels instantaneous by human standards, but is remarkably slow on a galactic scale. A communication sent from a civilization 500 light years away would take 500 years to reach us. If they dispatched it after picking up our earliest radio signals, it won't arrive here until the year 2524. And if we sent a reply, they wouldn't receive it until 3024. Any dialogue we have with our galactic neighbors will unfold on timescales so vast that entire civilizations could rise and fall in the time it takes to exchange a few sentences. This is not merely a technical obstacle. It is a profoundly strange characteristic of the universe that I believe we do not contemplate often enough. Communication across interstellar space is almost unmanageably slow, even at the universe's ultimate speed limit. A relationship with another civilization would span centuries for both parties. The civilization that initiated the contact might no longer exist by the time a response is received. Now I want to discuss a concept known as the rare earth hypothesis, because I feel it is often undervalued and it relates back to what I mentioned earlier about the great filter. We once believed that Earth was a fairly typical planet, a rocky world at a suitable distance from its star with water. Surely such worlds are common. But the more we discover, the more it seems that Earth may be unique in ways we hadn't previously considered. We have an exceptionally large moon. Our moon is massive in proportion to our planet. It's almost like a binary system. That moon stabilizes the tilt of our axis, which in turn stabilizes our seasons, providing us with a relatively consistent and predictable climate over millions of years. Without the moon, Earth's axis would wobble erratically. We have plate tectonics. The continents drift. The ocean floor is recycled. Carbon is sequestered from the atmosphere and then released, which has regulated our planet's temperature over geological epochs. Without plate tectonics, a planet is likely to either descend into a permanent ice age or become a runaway greenhouse in the long term. We are located in a tranquil region of the galaxy, far from the turbulent galactic center where intense radiation would make complex life exceedingly difficult. We have Jupiter, that colossal gas giant that functions as a gravitational shield, deflecting comets and asteroids before they can impact us every few millennia. If you remove any one of these factors, the story of life on Earth might have concluded prematurely, or it might never have properly started. So it's possible that life itself is common, simple microbial life perhaps. The building blocks of life, amino acids, form in space. We discover them in meteorites. They are not rare. but complex multicellular life that evolves over billions of years into a form capable of constructing radio telescopes? Perhaps that necessitates a very specific set of circumstances that do not align very frequently. Perhaps the universe is filled with bacterial colonies and algae and almost devoid of beings who can ponder its existence. Perhaps. I don't know, and I want to reiterate that I don't know because the truly honest scientist is the one who leaves the question unresolved. There's another possibility that I find philosophically intriguing, even if it is somewhat disquieting. It is known as the dark forest hypothesis, and it originates, fittingly, from a work of science fiction. But its underlying logic is sound. Imagine that every civilization in the galaxy is cognizant of the fact that other civilizations exist. And imagine that every civilization, regardless of its level of advancement, is confronted with a fundamental dilemma. If you encounter another civilization, you can never be certain of their intentions. And you can never be certain of their rate of technological progress. They might be benevolent or they might not. They might be benevolent now, but that could change in 1,000 years when they possess superior technology. The most prudent course of action, if your goal is survival, might be to remain concealed and to eliminate any other civilization you find before it has the chance to find you and potentially pose a threat. In this scenario, the silence we observe is not a sign of absence. It is a sign of prudence. Everyone is in hiding. Everyone is fearful. And any civilization that announces its presence loudly is swiftly extinguished. I find this possibility compelling in the same way I find a truly elegant mathematical proof compelling. Not because it is a comforting thought, but because it possesses a kind of internal coherence that is difficult to dismiss. It also forces you to think very critically about the wisdom of initiatives like messaging extraterrestrial intelligence, where we intentionally transmit high-powered signals toward particular stars. Some scientists argue that this is a profoundly reckless idea. If the dark forest hypothesis is even remotely accurate, then broadcasting your coordinates to the cosmos is ill-advised. Others believe it is of no concern because we have already been passively broadcasting for a century and no harm has come to us. Both arguments have their merits. This issue is genuinely unsettled. Let me now connect this back to something tangible, something I can physically reference because I always find the concrete more satisfying than the abstract when possible. We have been conducting SETI, the search for extraterrestrial intelligence, in various forms since Frank Drake's Project Ozma in 1960. That's over 60 years of searching. We have scanned millions of radio frequencies. We have examined hundreds of thousands of stars across multiple wavelengths, and we have found with one very notable exception that I will get to nothing. The notable exception is known as the wow-wow signal. In 1977, a radio telescope at Ohio State University detected a narrowband radio signal that lasted for 72 seconds and possessed the exact characteristics that SETI researchers had predicted they would find. It was powerful. It was at a frequency that is logical for interstellar communication, and it originated from the direction of the constellation Sagittarius. The astronomer who discovered it in the data circled the transmission on the printout and wrote, "Wow," in the margin, which is how it got its name. And it has never been detected again, despite decades of subsequent observation of that same region of space. It never returned. We do not know what it was. It might have been a natural phenomenon. It could have been interference from a terrestrial source. It might have been something more extraordinary. We truly do not know. This is one of those beautiful, unresolved questions that science is actually quite comfortable coexisting with, even if the public finds it frustrating. Here is what I want to leave you with. Here is the single most important idea I hope you take away from this discussion. The question of whether aliens will find us or whether we will find them is not merely a question about technology or radio telescopes or the Drake equation. It is a question about time. It's a question about what constitutes a civilization. It's a question of whether intelligence is a stable phenomenon or a brief, fragile flame that burns with intensity and then extinguishes. It's a question of whether we are typical or an exception, of whether the universe has produced a multitude of minds like our own or almost none. We do not have the answers. We have rough estimates and plausible beliefs and varying levels of uncertainty. We know the universe is incredibly ancient and immense. We know the chemistry that underpins life is not rare. We know that our search has been brief and narrow in its scope. We know our own signals are weak and have not traveled far. We know that even if other minds do exist, the buried geometry of the cosmos, the vast distances and the finite speed of light makes contact exceedingly difficult. And what I believe to be the honest scientific stance, not the thrilling Hollywood stance, not the fearful "we are definitely alone" stance, but the honest one is this: we don't know yet. We have not searched thoroughly enough for long enough or with enough ingenuity. The lack of evidence after 60 years of limited searching across a galaxy that is 10 billion years old is not yet strong evidence of absence. But I also believe, and this is the thought I cannot dismiss when I truly contemplate it, that the silence might be conveying something vital about the destiny of minds like ours, that the galaxy could be strewn with the remnants of civilizations that became smart enough to be dangerous before they became wise enough to be safe, that the silence might be what follows after the radio signals cease. And if that is the case, if that is the meaning of the silence, then the most crucial thing we can do has nothing to do with radio telescopes. It has everything to do with whether we can be the first, or one of the few, to navigate whatever filter lies ahead. I do not know if we will succeed, but I do know that understanding the question with honesty, not the romanticized version, not the comforting version, but the real version with all its ambiguity and all its strangeness, is the proper place to begin. Because the universe is not concerned with whether we are pleased with the answer. Nature cannot be deceived. And the first principle is that you must not deceive yourself. That is all.